Squeeze theorem is an indirect way of evaluating a limit of a particular function. So say there's a somewhat complex function, say f at x. As it's approaching a value of a, say that it is somewhat always less than h at x, another simpler function, and say there's a lower bound of g at x. So if you want to evaluate limit as x is approaching a, and as it's getting close to a, if this relationship holds, then what we can do is we can evaluate limit as x approaches a of this particular function, and limit as x approaches a of this particular function, and see what kind of a value these two give. And as long as this is sort of sandwiched in between the two, then in that way indirectly we can sort of make a conclusion that this is also going to be approaching the value that's in between the two. So that's just the basic concept of squeeze theorem. Let's go ahead and try a couple of questions. So here we have two examples. Here the question says evaluate this particular limit using squeeze theorem. So evaluating this without squeeze theorem would be kind of hard to do. This will be 0 and this will approach 1 because cosine anywhere 20 pi, this just changes the cycle, but anywhere where you've got 0, that's going to cosine is going to be 1. So 1 times 0 is going to be 0. By using squeeze theorem, how do we prove this? So here we know that for cosine it's always going to fluctuate between top and bottom. So if you were to illustrate this, here is x and here is y. So 20 cycle means one cycle is 2 pi. This is the k factor for transformation that goes in the denominator. So the pi's will cancel out, so it will be 1 over 10, which is 0.1. So when it comes to 0.1, this is going to be 0.05. That's where complete cycle will take place. So here we've got 1, and here we've got -1. We know that cosine will always fluctuate over between +1 and -1. And also for this particular function, there has been no vertical stretch in any direction. So here, our graph will look something like this. So we know that cosine will always be between 0, -1, and 1. So here we can say cosine 20x, this 20 just means the cycle's been compressed by the factor of 1 over 20. So this will be less than or equal to 1 always, less than or equal to -1. This is a graph only representing this function right here. As we multiply both sides by x to the power of 2, then we can establish this relationship by squeeze theorem. Be -x to the power of 2, x to the power of 2, cos 20 pi x less than or equal to x to the power of 2. Because for any value of x, because it's squared, it will always be positive, it doesn't switch these inequality signs. Then let's apply limit and see what happens. So as you apply limit as x approaches 0, and also limit as x approaches 0, and limit as x approaches 0, since limit approaches 0, we know that this value is going to approach 0 because it's a continuous function over any domain. It is a quadratic function, so 0 is part of the domain. It's everywhere this function exists, and so we can just plug it in. Then this is going to be 0, and limit as approaches 0, x squared cos 20 pi x less than or equal to, also 0 here as well. Just a negative sign attached to it. That means it's facing up. This is facing down. This is facing up. So because this is squeezed between 0 and 0, therefore we can conclude that this particular limit value is also going to be 0. So this is going to be 0 according to squeeze theorem. Now let's look at the second question. Here we have a function. We don't know what it is. But the question says find the limit as x approaches 4 for this particular function. And this relationship is established, the lower bound and the upper bound, for all x value greater than 0. And we know that for approaching 0, this falls into this domain, this restriction, so to speak, that we have. And so we are safe to just substitute this right in because this is a linear function, this is a quadratic function, they're continuous everywhere, especially for all x greater than or equal to 0. And so when we plug it in, these inequality signs will remain the same. So let's try and see what happens as we plug it directly into this equation. Then we have here 4 times 4 minus 9, and that's limit as x approaches 4 of this particular function. 4 to the 4 squared is going to be 16. 4 times 4 is 16 plus 7. Sorry, actually this should be negative. I copied the question wrong. So here it's negative. Okay, so here we've got negative and here we've got negative. So if we evaluate this, we have 16 minus 9 less than or equal to limit as x approaches 4 f at x. And these two 16s will cancel out, so we will just have the value of 7. As we evaluate this, this is 7 as well. So if this particular limit is caught between less than or equal to 7 and greater than or equal to 7, there's no other way this can escape but be 7. So we can say that the limit, so to answer this question, find the limit of this, the answer is equal to 7. So this is the basic concept of squeeze theorem. It's not too hard. It's just as the value is approaching particular number, in this case a, you can plug it in and see what happens. So in this case, limit as x approaches a of h at x is going to be, say, h at a, given that it's continuous. The textbook denotes this value as L. So let's say this value is L, this value is L, then this value will also approach L as well because it's squeezed in between the two.